There are four factors affecting reaction rate. Number 1, concentration. Number 2, particle size. The third one is catalyst. And the fourth factor is temperature. In this video, we're going to look at the factor of concentration. So based on the collision theory, if you have the concentration of reactants is increased, the number of reactants particles will also going to increase. And when you have the number of particles increase, therefore the number of collision will also going to be increased. So collision frequency refers to how frequent the reactant particles are colliding with one another. So the key word over here is frequent. Okay? So is it going to be quite frequent, low frequency, high frequency for the particles to be colliding with one another? Remember, for a reaction to happen, the first thing the molecules need to do, they have to collide. Therefore, when the collision frequency is increased, we are going to be increasing the chances for effective collision to occur. More frequency, more collision, more effective collision going to be able to take place. Therefore, the rates will also going to be increased. So the reaction rates, we can say that the reaction rates is directly proportional to the concentrations of reactants. So how do we see that relationship? If the concentration is increased, the rates will increase. Vice versa, when concentration decreased, the rates will also going to decrease. But we need to remember, zero order reactions, the rates of reaction will not going to be affected by the concentration of reactants. The reason is because if you look at the rate law for zero order reaction, you have rate equals to K. If you go back to at the beginning of the chapter for reaction kinetics, when you have reactants to be converted into products, if the order is 0 with respect to the reactants, we can write the rate law in this form. Okay, the rate law will be rates equals to rate constant, concentration of your reactant to the power of 0. Mathematically, concentration or any number to the power of 0, you will have 1. Therefore, you can rewrite the rates for zero order in this way. So this is the rate law for zero order, and this is the proof that zero order reaction is not affected by the concentration of your reactant.